I'll continue where the other video dropped off. So we were looking for exponential decay in number 4, and I had eliminated b because that's the one to look at it easiest. The b is 4/3, right? The b is the one that has to the x power, and 4/3 is greater than 1, so that means this is growth. So I have eliminated that one. Letter A says b is greater than 1. We just said that for decay it has to be less than 1, so no A. For letter C, you need to find the common ratio, which is the b. Okay, so for this sequence, I need to know what the common ratio is. Okay, if it's less than 1, then this is going to be decay. So here, 6 to get to 3, I would multiply times 1/2 times 1/2, right? 3 times 1/2 is 3/2, times 1/2 is 3/4, and so forth. So this one is the common ratio, or the b is 1/2. So this is decay. And just to double check, I'll do D. D says that the sequence has a common ratio of 3. So again, the common ratio is the b. That means b is 3, and that is greater than 1. So this is going to be growth. So my answer would be C. C would be the correct answer, decay. All right, for number 5, we need to identify several things without a calculator. Okay, the domain, range, asymptote, and y-intercept. So from all of these, the easiest is the y-intercept. Okay, this is the 1/3 is my A, which is the y-intercept. And the 1/2 over here is the B. Okay, so y-intercept is 1/3, or you can put 0 1/3. Okay. So all of these domain, because this has no context, I know that the domain will be all real numbers without even looking at it, because there's no word problem and I don't know what it means, what the x or the y are. Okay, now I need the asymptote and the range, which go hand in hand. Once I find the asymptote, I can find the range. So if you were to graph this, your y-intercept is 1/3. So if this is 1, this would be your y-intercept. Okay? And then you're going to be decreasing. In fact, let me write it larger. If this is 1, right? This is 1/3. This is your y-intercept. And then the 1/2 means that this is a decay. So it's going to be going down like this. Okay? So it probably came from here and it went like that. So if this is the case, that means that the asymptote, oops, I forgot the M, asymptote is y equals 0. Okay, so I'm going to put it over here. Y equals 0. And the range is going to be, since this is on the top, y is greater than 0. Okay, so ignore this one. I made it larger. You can plug in numbers and make a table if you like. When x is 1, right, you're going to have 1/6, so it's going to be closer and so forth. So it's going to be smaller and smaller and smaller. So this is what it's going to look like. Remember that we need to do it without a calculator. All right, for number 6. An adult takes 500 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases about 27%. Write a function that represents the ibuprofen after X hours. Okay, so now we know that X is hours and Y is the ibuprofen, the milligrams. Okay, so this is my A. So A is a 500, that's the amount they started with. Okay, whatever unit your A is, that's what's going to be your Y. Notice that the A is milligrams, so your Y is milligrams. Okay, my rate is 27%, or 0.27 or 27 hundredths. So that means my B, because this is decrease, this is going to be B equals 1 minus. So 1 minus the 0.27. Okay, it's going to be 0.73. so now I can put it all together. I can say y equals 500, and then it's going to be the 7300s is my b to the x power. So this would be my equation. All right, number 7. A number of students at a college can be modeled by the function S of t equals 25,000 times 1/400 to the t power, where t is the number of years since 2015. According to the model, what does a 25,000 represent? Write in complete sentences. So I know that the 5,000 here is the A, right? In this case, initial value, or the y-intercept, right? But in the context of this, we're talking about college students, so that means that there are 25,000 students, okay? And then it's the initial, when it first started, and then we notice that years since 2015, so this is where the start of this experiment was, in 2015. So there are 25,000 students in 2015. Okay, this is the initial value. Okay. All right, so for number 8, the number of acres of ponderosa pine forests can be approximated by the formula P equals 41 times 995 thousandths to the t power, where P is the number of acres in millions and T is the number, the time in years. Okay, so since 1963, how is the number of acres in ponderosa pine forests changing? Okay, so we're going to take our equation and figure out how is it changing. I'm going to look over here at the B, and this is less than 1, so this has to be a decay, right? So that means that 995 thousandths is the decay factor. Okay? In percent, let me do that, in percent, 99.5%. This is my B. Because this is decay, I got my B by doing 1 minus, or in this case, as it's in percent, 100% minus what I'm looking for, and I got the 99.5%. Okay? So that means that what I'm missing is that 0.5%. Okay? So that means that the ponderosa pine forests are decreasing at a rate of 0.5%. Okay? Decreasing. All right, and that will be all for the review. Good luck, and I hope you study.